Hello, in this video I'm going to take you through an introduction to integration. The agenda for this lesson is we are going to cover the rules of integration. What are the rules that I have to follow to be able to integrate a given function? We're going to talk about the difference between definite and indefinite integrals, and we're going to take examples on each. And regarding the applications of integral, we're going to cover only one application, which is the area under a curve. Integration. What do we mean by integration? Well, you can think of integration as the reverse process of differentiation, meaning that given a function, let's say y equals to x squared, if I derive this function, I would get using the rules of differentiation 2x. How about if I was given the derivative, which is the 2x, and I want to figure out what is the function that if I derive, I get a 2x. So I want to go backwards. Given 2x, I want to get to the x squared. Here I use integration. So that's why we think of integration as the opposite process of derivation. How do I express integration in maths? I use the elongated S. So this is the symbol of integral. The integral of this is the function that I want to integrate, which is actually the derivative that I want to figure out what is the original function that if I derive, I get this. And this is in terms of x, so dx. This is going to give you the value. So here I've got 2x. If I integrate it, I get the original function, which is x squared. But this answer is not precisely correct. Why is that? Because I've got so many functions beside the x squared that if I derive, I get the function 2x. So x squared plus 0, I derive, I get 2x. Moreover, x squared plus 4 or plus 3 or negative 6, whatever the constant that is added or subtracted from x squared is, if I derive these functions, I'm going to get 2x plus 0 because the derivative of any constant is equal to 0. So I've got actually many answers. It's not only x squared that if I derive, I get 2x. So a more precise answer to the integral of the function 2x in terms of x is equal to x squared plus a constant. Because as we said, if we want to derive this, we get 2x plus 0, which is this function. Now, what are the rules of integrals, or what are the rules of integration? Well, let's talk about the basic functions right here. We're going to start with the power function. The integral of a power function, all you've got to do is take the power, increment it by 1, and then divide by the new power. So if we're talking about ax to the power of n, of course a is just a constant, I just leave it here. X to the power of n, I'm going to take n, add 1 to it, it becomes n plus 1. I take this new power and I divide the entire thing by it, so division by n plus 1. And don't forget about the plus c. Alright, let's go to the trig functions. The integral of cos or cosine of ax is going to be equal to sine of ax. And then you're going to divide by this number. Okay, so unlike the derivation, the integral of cosine is equal to positive sine. And also similarly, the derivative, the integral of sine, is going to be negative cosine. So it's quite the opposite of derivation. Cosine is positive sine, sine is negative cosine. And don't forget that you're going to divide by the a right here. Okay, if you go to the exponential function e to the power of ax, the integral of it is the same function e to the power of ax, and then you're going to divide by this a. The last one is 1 over x. If you're thinking, what is the function that if I derive, I get 1x? Well, that is the ln x, right? So if you have 1 over x, then you want to integrate it, the integral is going to be equal to ln of x, and of course plus c. Let's apply these rules. I've got this example. It says determine the integral of 7x squared dx. Before I get into this, you can see that the title says these are the indefinite integrals. Indefinite integrals, these are the integrals that do not have any limits defined for them. So you can see just the stretched s without any numbers on top and the bottom. These are indefinite because it does not give you a value at the end. You can't evaluate this integral. It's going to give you at the end an expression. Unlike the definite integrals, when you've got a definite integrals, you're going to have limits. You're going to have an upper limit and you're going to have a lower limit. And then you're going to be able to evaluate the integral to give you a certain number. All right, so let's go back to indefinite integrals, okay? And I'm going to apply the rule of the powers right here. 7x squared dx. I've got the 7, which is just a number. And then I'm going to integrate the x squared. It gives me x to the power of 3 because I have to increase the power and then divide by the new power, which is 3. And don't forget about plus c. Let's take another example. Determine the integral of 2t to the 3 dt. Again, I've got the 2, which is just a number. And then t to the power of 3 using the power rule. I'm going to increment the 3 by 1. It becomes t to the power of 4 over the new power, which is 4 plus c. All right. Now, what you can do is that you can just simplify this. You can divide by 2. So over 2 is 1, over 2 is 2. So it becomes t to the power of 4 over 2 plus c. A third example, you've got the integral of 8 dx. So you can't see any x's here. How would you apply the rule of integration, like using the power rule to this? Well, if there is no x, I can introduce the x. X to the power of 0 is equal to 1. And I know that 1 multiplied by anything is going to give me the same thing. So this is the same as the integral of 8x to the power of 0 dx. Now what I have to do is use the rules, the rule of power. You've got 8, which is just a number, and then you've got x to the power of 0. I'm going to increment it by 1, it becomes 1, and I'm going to divide by the new power, which is 1. This is going to be equal to 8x. You don't have to write to the power of 1, so this is 8x plus c. Another example, the integral of 3 plus 2 over 5x minus 6x squared dx. Well, in this case, I've got many terms added and subtracted. I'm going to do each one separately. So I'm going to start with the 3, just like the example here on the top. I've got a constant, so to integrate it, the answer is going to be equal to this number and then multiplied by x as we saw here, because you can imagine this as multiplied by x to the power of 0. I increment it by 1, becomes x to the power of 1, and then divide by 1. So this is 3x. We go to the next term. You've got 2 over 5. This is 2 over 5. And then the x, this is x to the power of 1. I increment the 1 by 1. It becomes 2. And I divide by the new power 2. Well, here I have got some simplification that I can do. The 2 can be crossed out with the 2. And I'm going to be left with x squared over 5. Let's go to the last term. You've got negative 6x to the power of 2. Well, negative 6, this is a constant, and x to the power of 2, I increase 1, becomes to the power of 3, divide by the new power, which is a 3. And then I can do some simplification right here as well. Over 3 is 1, over 3, this is 2. I'm going to rewrite the whole thing to make it in a nice way. So this is 3x, this is x squared over 5, and this is minus 2x to the power of 3, and don't forget plus c. Another example, you've got the integral of 2x to the power of 3 minus 3x, and this is all over 4x dx. To make it in like a form which is easy to integrate for me, what I'm going to do is that I'm going to separate the two terms. This is all over 4x, which means this term is over 4x, and this term is also over 4x. So that's what I'm going to do now. This is the same as the integral of 2x to the 3 over 4x. and then minus 3x over 4x. You can see that I can do some simplification right here over the 2. This is 1. Over the 2, this is 2. And then you do the same thing, just rewrite into, also you can do it with the x's. So over the x is 1, and then x to the power of 3 over x. This is going to be equal to x to the power of 2. In the other term, you can see that I can cross out the x's, and I'm going to rewrite this. It becomes x squared over 2, and here you've got the constant minus 3 over 4. Now I'm going to do my integration. My integration here is, you've got x squared over 2. So to integrate it, what I'm going to do is take the power, x to the power of 2, increase the power by 1. It becomes x to the power of 3, and then I'm going to divide by the new power, which is a 3. If you go to the other term, it's a constant. If you remember, if we've got a constant, to integrate it, I just attach the x to it. So minus 3 over 4 multiplied by x. And then I'm going to rewrite it again, doing the multiplication right here. So you've got x to the power of 3, and then you've got 2 multiplied by 3, that is a 6. And then I'm just going to type this, rewrite it as it is, and then add plus c to it. All right, one more example, the integral of negative 5 over 9, the 4th root of t cubed with respect to t. What I'm going to do is that I'm going to change the 4th root t to the power of 3. First, I'm going to get rid of the 4th root. So this is going to become 3 over 4. And then I've got t to the power 3 over 4. I want to put it up on the numerator. So it's positive right here. If I put it up, it becomes negative. So t to the power of 3 over 4, and it is going to be negative. All right, I'm going to apply the rule, which is the power rule. Negative 5 over 9, this is just a number. I'm just going to put it here. And then you've got this one. You've got to increment 1 to it. So increase 1 to it. This is like adding plus 4 over 4 to it. So this is going to give you 1 over 4. So this is t to the power 1 over 4. You take this new power, which is 1 over 4, and you divide the entire thing by it. Well, it could be rewritten in a nicer way, because I usually don't like two fractions in one thing. So I'm going to get rid of the 1 over 4. This is division by 1 over 4. So I can convert the division into multiplication, and I can swap these. I can flip it. So instead of 1 over 4, the reciprocal is going to be 4. So division by 1 over 4, this is the same as multiplication by 4. So let's do it. I've got the negative 5 over 9, which is the constant right here. I've got my t 1 to the quarter. And then I am going to multiply by the reciprocal of this, which is simply 4. I'm going to multiply these numbers together. I get negative 20 over 9. And I change the fraction power as a root again. So this is the 4th root. And don't forget about the plus c. One more example. You've got the integral of 2x squared plus 1 all over x. As you can see, we did this before, and we separated the two terms. We can see that I can divide each term by the x. So that's what I'm going to do now. I'm going to have 2x squared divided by the x, and the other term 1 divided by x. I can do some simplifications right here. So in the first term, I can cross out 1x with one of the x's from the x squared, and I'm going to leave this as it is. Now I'm going to do my integration. Here I'm just rewriting it. This is 2x, and this is plus 1 over x dx. I'm going to start by integrating the first term, 2x to the power of 1. This becomes 2x squared, and then I divide by the new power, which is 2. We can cross out the 2 and the 2, And then for the other term, 1 over x, the integral of it is ln of x. I'm going to rewrite this. So this is x squared, and this is plus ln of x. And then don't forget about the plus c, the constant. Now here we've got a trig function. I've got the cosine. So what I've got to do, I've got the 4 here. Of course, I'm just going to leave it as it is. All right? And then remember, cosine of something is equal to sine. All right? It's the opposite of differentiation. So if you integrate the cosine, it's going to give you positive sine. So positive sine of 3x. And don't forget to divide by this number, which is a 3. Plus c. Another example on trig functions. I've got the integral of 5 sine of 2 theta d theta. This is in terms of an angle theta. It's the same concept. So I'm going to take the 5, which is a number. I'm going to put it here. The integral of sine is negative cosine. So negative cosine of 2 theta. And I'm going to take this 2 and divide by it. I'm going to take these two numbers and the negative sign, put them in a fraction. So this gives me negative 5 over 2. And then I've got the cosine 2 theta plus c. Another example. You've got the integral of 2 over 3 e to the power of 4t with respect to t. And what I'm going to do is that I'm going to take the e and raise it up. This is to the power of 4t, so if I raise it up in the numerator, it is going to be e to the power of negative 4t. So this is the same as e to the power of negative 4t. Now I'm going to start my integration. Of course, you've got the 2 over 3, which is just a number. I'm going to put it here. This is the exponential function, which is really easy to integrate. I'm just going to take this and copy it, and then I'm going to divide by this number, negative 4. I can do some simplification, so over the 2 is 1, over the 2 is negative 2. I'm going to rewrite it. So here I've got 3 at the denominator. 3 multiplied by negative 2. This is negative 6. I've got e to the power of negative 4t. This is negative, a negative power. I'm going to get rid of the negative power by putting the e down here at the denominator. So it becomes e to the power of positive 4t plus t. Plus c. Now let's get to the definite integral. These are definite integrals because I can evaluate them and get a certain value. And we're going to have 2 limits defined here. You've got the upper limit, which is the one on the top, and you've got the lower limit right here. Now how do I evaluate? Well, the first step to do is to integrate first, regardless of whether I have an upper limit or a lower limit. Regardless of these values, the first step is to integrate and get an expression for the integral of the function. Now that you've got the answer right here, what you've got to do is first substitute with the value, which is here, the upper limit, and then substitute another time with the lower limit, and then subtract the 2. So the first thing you're going to be doing is to integrate this, get an answer, take the upper limit, substitute in the answer, take the lower limit, substitute in the answer, and subtract the 2. Let's apply this to this problem. So here I am going to start by integrating 3x. The integral of 3x is you've got the 3, which is just a number, and then you've got the x to the power of 1, it becomes x to the power of 2, all over the new power, which is 2. And then I'm going to evaluate this with the upper limit, which is 2, and the lower limit, 2. The first thing is that I am going to rewrite this. I'm going to take the 3 over 2, which is just a constant outside. I don't want to evaluate this using this, which could be a common factor. I can just take it outside and substitute into the function. So the first thing is that I am going to substitute with the 2, the upper limit, and then I am going to substitute with 1, which is the lower limit, and then I'm going to subtract the 2 from each other. Alright, so I've got the 3 over 2 right here. First thing I'm going to substitute with the 2, so instead of the x, you're going to put a 2, minus and instead of the x, you're going to substitute with the 1. All right, so substitution with the upper limit, substitution with the lower limit, there is a minus sign in between. And put all of this into bracket, multiply it by the 3/2, which is the number that you left outside. Now 3/2, 2 squared, that is 4, 4 minus 1, that is 3. Can multiply these, 3 multiplied by 3, that is 9/2. And this is the final answer. So you can see that after I evaluated it, I got the integral as a certain number. Now let's go to another question. Evaluate this integral from -1 all the way to 1. So these are the upper limit and the lower limit. Now we've seen this before. This is all over x. So what I'm going to do is separate the three terms by dividing by x. So I'm going to rewrite this. The first term is x to the power of 4 over x. Second is -5x squared over x. And third is x over x. I can see that I can do some simplifications right here. So in the first term, one of the x's here is going to go with one of the x's on the top. So I'm going to be left with x to the power of 3. For the second one, the x here at the denominator is going to cross out with one of the x's on the numerator. So I'm going to be left with 1x on the top on the numerator. So this is -5x. And here the x with the x is going to be crossed out, and I'm going to be left with 1. Now, we said if we've got a definite integral, the first step is to integrate regardless of these numbers. So that is what I'm going to do. I'm going to integrate this function. So this is x to the 3. It becomes x to the 4. Divide by 4. I go to the next one, -5. This is going to be x to the power of 2 over 2. And the last one, this is 1. So this is a constant. I just have to attach x to it. So 1 multiplied by x, this is x. And now I am going to evaluate it at the upper limit, then minus evaluate it at the lower limit. So let's do it. I'm going to start with the upper limit. And whenever I see an x, I'm going to substitute it with 1 with the upper limit. So 1 and 1 here and 1 here. Minus. Now I'm going to substitute with the lower limit, which is -1. And be careful if you've got a negative number, okay, and you're raising it to a power, please put it between brackets so that the entire number gets raised to the power. It's not only the number without the sign. This is the entire number with a sign raised to the power. So I just replaced the x's with -1 right here. And at the end, I'm going to evaluate this and evaluate this on subtracting. And of course, if you've got a calculator, you can do all at once in your calculator. So this is, at the end, it's going to give you the number 2. So if I evaluate this definite integral, I get a certain value at the end. And in this case, it is equal to 2. Let's take some examples on trig functions with definite integrals. So we said the first step is to take this function and integrate it. So to integrate it, before we get into that, let me just remind you that if you're integrating trig functions and you've got to evaluate, you've got an upper limit and a lower limit, you've got to evaluate this integral. Be careful that if you're doing this using the calculator, then your calculator has to be in radio mode. Okay? So with trig functions, the evaluation, your calculator has to be in radio mode. So you've got to switch it from degree to radio. All right. Now let's go to the first step of doing this. That is integrating the function. So you've got a 3 here. You're going to leave it. And then you've got the sign. The integral of sine is negative cosine. So you've got the negative here and you've got the cosine here. And then you've got 2x. And you've got to divide by 2, so I divided here by 2. So you've got -3 cosine of 2x over 2. And I'm going to take this and I'm going to evaluate it at the limits, the upper limit and the lower limit. All right, so I'm going to start with the substitution with the upper limit, which is pi over 2. So instead of the x here, I put pi over 2, and I took the -3 over 2 outside because I don't want to repeat it here inside when I am substituting. So I took it out, and then I started my substitution. Okay, so I substituted with the upper limit first. minus, then I substitute it with the lower limit, which is the 0. Okay, so you can see here that there is a 2 and a 2. I can cross them out, and I'm going to be left with cosine of pi. So if we rewrite this, this is negative 3 over 2. I've got here cosine of pi, and then 2 multiplied by 0. This is equal to 0. All right, negative 3 over 2 cosine of pi is equal to negative 1. If you know it, then this is a great. You don't need the calculator, but if you forget about these things, you have to use radian mode in your calculator. Okay, so cosine of pi, this is negative 1. And then you've got minus. You put the minus. Cosine of 0, this is 1. Negative 3 over 2. Negative 1, this is negative 2. You multiply these together. The negative 2 is gone with the negative 2, and you're left with a 3. So to evaluate this, I get a certain number, which is a 3. All right, and that's what makes it a definite integral. But please don't forget about changing your calculator to radian mode when you're doing trig functions and you're evaluating definite integrals.